In this video, what I'd like to do is introduce our new unit of study, Chapter 4, Solving Polynomials. And in this video, I want to cover a couple things. I want to look at the relationship between factoring, solving, and just some general characteristics as graphs. I also want to take a look at some of those factoring techniques that we've learned in the past, especially when we learned how to solve quadratic equations. And I want to try to tie in the relationship between all of them. So this is just going to introduce the unit that we're going to be in for our final unit in the semester, which is once again, Chapter 4, Solving Polynomials. So we looked at factoring and using factoring to solve. And we also can think about factoring and solving as they relate to these polynomials themselves, the graphs of them, the characteristics of them. When I solve an equation, what am I actually finding graphically? When I find the x-coordinate that makes the function 0, graphically, what did we just find? So first of all, with factoring. So we looked at factoring as this way of undoing distribution. So if you had a problem that was all multiplied out already, we had a couple techniques for factoring. The first method for factoring is we did GCF. You always start there. That's called greatest common factor, which is just a kind of a basic concept saying this. If you have 2x squared plus 6x plus 8, the greatest common factor is the biggest number that each of them, or that goes into each of them, or the biggest number that makes 2, 6, and 8 divisible. It's divisible by this value. So if I were to take a look at the 2, the 6, and the 8, I know that 2 goes into or is a factor of each of these. So I could take out the 2. I could undo the distribution. And we're left with that. And then we look to see, after we've done GCF, could we factor potentially a quadratic where the a value is 1? Well, when the a value is 1, it is the easiest form of factoring for quadratics. So here's an example. X squared plus, let's go 7x plus 6, okay? Notice the a value is 1. There's 3 terms here. When we factor this one, we go right away to the 2 sets of parentheses, and we try to find our combination of numbers that works here. If we were to multiply this all out, remember these 2 first values here and here give us that x squared. So what has to go there? An x and an x. To multiply, do the foiling to give us an x squared. But then we have to find 2 numbers that multiply to a times c and add to the b value. That's the math puzzle, the number puzzle that we have to find here. So what are 2 numbers that multiply to a times c? Well, the a value is a 1, the c value is a 6. A times c is 1 times 6 is 6. These 2 numbers have to multiply to 6, but they have to add to b, which is 7. But what multiplies to 6? 1 and 6, or 2 and 3, right? For some of us, this is a quick mental math problem. Others of us, you may actually have to write that out. 1 and 6, 2 and 3, find your multiplies 2 so that you could find your combination. Well, what 2 numbers work here? 1 and 6. So that's our solving technique when a quadratic, when the a value is 1. So what does that mean here? We used factoring as a way to find an equivalent form of a function, but it was this form of the function that made it very easy in solving. So we looked at solving quadratics through a factoring technique. So let's just change this a little bit and say, let's say we have x squared plus 7x plus 6, and we want to set that equal to 0. Well, what's one way we could solve it? We could use quadratic formula. We could maybe potentially try to graph it and find the zeros, or in other words, tie in here characteristics of polynomials, the x-intercepts. We could use factoring to solve. So if I want to now find x plus 6 times x plus 1, what x value makes it 0, really focus in now on these individual linear factors, and I can ask myself the question, what x value will make x plus 6 equal to 0? That's what we're trying to isolate. We're saying, okay, we got an x plus 6 here. It's being multiplied to something else. Well, if I can find the x value that makes that 0, 0 times anything is going to be equal to 0. So I found a solution. So we could look at it and just say negative 6. We could also look at this one and say negative 1. Those are our 2 solutions. If you didn't see that off the top of your head, then you actually have to solve an equation, which is x plus 6 equals 0. Solve it by subtracting, and we get our first answer, -6. Same thing here. What x makes x plus 1 0? That would be x plus 1 equals 0, x equals -1. So we use factoring as just this method to undo distribution. That's what factoring is. But a way in which you can use it is through the solving process. And then the final tie-in here, real quick, is the idea of what did we just find? Okay, let's say we actually had this, x squared plus 7x plus 6 equals y, is y equals, okay? Let's say we have that as our function. Now, if you have a y equals equation, that means you got x's, you've got y's, you've got points, you can plot points and sketch a graph. Well, let's say we want to set the y value equal to 0. When we solve for x when y is 0, the question is, what are we finding, right? Think about any time you look at a graph. When the y value is 0, that means that point is on the x-axis. So what are we finding? X-intercepts. So if I were to do this and say the directions could instead say find the x-intercepts, find the zeros of the function, 7x plus 6 equals 0. I could solve this by factoring, and I could get the two answers as -1, -6. So where are the x-intercepts? -1 comma 0 and -6 comma 0. So we're looking at factoring as just being this technique to get us to something. It gets us to solving. It gets us to understanding characteristics of polynomials. And in this slide that you see here, that's the connection between the three. Now, we're solving polynomials in this unit, which are not just quadratics. A quadratic is a polynomial, but there's also cubic and quartic and quintic, all these other types of functions. So we have to have more than just one technique in factoring. GCF is great. Quadratics where the a value is 1 is great. But we're also going to have to be able to factor using, so third method, we're going to have to be able to factor a quadratic where a is, I can say, greater than 1. So this is, Mr. Dussel put a video together on this. This is where you can use that box method. You can also use a guess and check method if you're comfortable with that. But it still revolves around the same process. Let's say we had this, 2x squared minus 5x plus 3. And the directions just said fact. Okay, I need to find two numbers that multiply to a times c, but they need to add to b. So we have to actually write this out and find our combination. A times c is 6. The b value is -5. So what two numbers multiply to 6, but at the same time add to -5? Notice how the multiplication is positive. That means both numbers are either both positive or both negative. But if it adds to a negative, it means it has to be this. Both are negative. So what numbers multiply to 6? 1 and a 6, 2 and a 3. If they're both negative, which one is it going to be? -2 and -3. So here's the issue with this quadratic. We can't just do this. -2, -3. Why? Because there's a 2 here. It's throwing off that process of when the a value is 1. So I can't just end it there. Okay. You also can't just say, I'm going to put a 2 here and that gives me 2x squared. Yes, it does, but do the distribution, it throws off everything else. It doesn't actually get you back to what we need. And you can't just say, well, what if I just threw it here? No, same thing. You can't just put the 2 wherever you want. It actually has to get back to the original value. So this is where we found our combination. Now what we can do is just that box method. And it takes like 30 seconds, but it's something we got to do. 2x squared goes there, the 3 goes there. We're breaking apart -5 using these two numbers, and we put a -2x there, and we put a -3x there. It doesn't matter the order that they go. And now you just do the GCF around the rows and columns, and you have your answer for the factors. So yes, it takes a little bit of work with the setup, but then you'll consistently get to the right answer. So the GCF here is just an x. The GCF here, it starts with a negative, so it's not just 1, it's -1. the GCF here is 2x, and then here starts with a negative, and the GCF is 3's negative 3. So what is my answer? 2x minus 3, x minus 1. And we've got our factors. And I take that back, sorry, it's not even set equal to 0, it's just asking to factor. So that's a technique we saw in the past. So I've run through so far factoring, GCF, factoring the quadratic when the a value is 1, and factoring a quadratic when the a value is greater than 1. So all a review of things we saw in previous units, and also tied into solving, and then also graphs of characteristic graphs and x-intercepts. In this unit, though, we are going to solve higher level or higher degree functions. X to the third plus 4x plus 8x plus 32 equals 0. And you're going to be asked to solve. So notice there's 4 terms. Notice the degree is a cube. It's a cubic function. The degree is 3. So we can't use our quadratic technique, right? So we're going to have new techniques for factoring. And that's what we're going to learn day 1. So new techniques in factoring. One of them is called factoring by grouping. One of them is referred to as factoring using difference of squares, using GCF and then factoring quadratics. So we're going to see new techniques for factoring. Why? Because then that leads to finding the zeros of the factors and we can solve. Okay, so that's the goal of this unit. There'll also be some applications tied in as we go, and maybe using our calculator to solve those applications. That's it for today.